Welcome back, and today we're going to talk about properties of exponents. Specifically, today we're doing the product of powers, and we'll also be talking about the quotient of powers. We got to remember with product, that's going to mean multiplication. So, the idea of the product of powers is this. You're going to have a number to one power times the same number or variable to a different power. Now, these guys have to be the same exact term. Could be variables, could be numbers. And then that's going to give us a to the m plus n power. So we would add these two values, and that's going to be our new power. Okay. Now, you're going to be able to do those. Here's a few examples. You can do that if you have something like x squared times x to the fourth power. That would just be, x to the 2 plus 4 power. 2 plus 4 is 6, so x to the 6th power. There we go. That also works for numbers. If you were to have like 5 to the second times 5 to the second, you just add the numbers. 2 plus 2 is 4, so this could be written 5 to the 4th power. Your teacher might want you to actually put that in your calculator and put a number instead of just a number to a power. So make sure you actually follow the directions. You can also see this with multiple exponents or multiple terms like x times x to the 3 times x to the 3. And right here, you're going to notice, okay, the first term doesn't have a variable or doesn't have an exponent. If nothing's there, it's an invisible 1. So we're going to put that in there. So this would be x to the 1 plus 3 power. We add all the exponents on the same exact terms, and that gets us our final result, x to the 7th. Boom. Okay. Now, you can have other variables in there, like something like this, x to the 3rd times y to the 5th times x to the 4th. You kind of chunk these problems. So you're going to look at both your x's and work with those individually. So that's going to be x to the 3 plus 4 power, and that's going to give you x to the 7th. And then y to the 5th is just hanging out, so we just bring that y to the 5th right here. We don't combine those variables. This is actually as far as we can go. Now, what if we have numbers? I got a couple examples over here to show you. The idea with numbers is we need to multiply the numbers. It's my star, working on it. We need to multiply numbers and then use the rule from the previous page, add the exponents of like terms. Okay, so on this guy right here, we're going to go 4 times 3, and that's going to give you a 12. And then you're going to use the exponent property rules on your x term. Ooh, this guy doesn't have an exponent. Let's put a 1 in there. So that's going to be x to the 2 plus 1 power. That's going to give us a 3, x to the 3rd. And this y is just chilling, so we just bring it right down. Boom. There we go. The last guy, I tried to make it a little more tricky, so you got a few things going on here. Well, we multiply our numbers. So 2 times 5 is 10. And then we add the exponents on our x's. So 3 plus 3 is 6, x to the 6th. And then we add the exponents on our y's. That's going to give us y to the 4 plus 5, 9. Bop. There we go. Now, that is the product of powers. Product, of course, has to do with multiplication. Now, I also want to touch real quickly on the quotient of powers. Usually these guys are introduced in the same lesson. Quotient, of course, means divide. And that happens when you take a number or variable to one power and you divide by the number or variable. Same deal. Well, instead of adding here, we're going to subtract these two powers. In my brain, I like to think, oh, that divided by sign kind of looks like a big old minus. That just helps me remember. So this guy is going to be a to the numerator minus the denominator power. All right. So with our variables, it would be like x to the 5 over x to the 2. We would subtract the two powers. So x to the 5 minus 2 power. And that's going to give you x to the third power. Boom. Okay. Now, what if there's multiple terms or numbers? Like here's this guy. 8x squared y to the third all over 4xy. Well, what we need to do here is we're going to divide the numbers like normal, kind of like we multiplied the numbers like normal with the products. So we're going to divide the numbers just like normal. And then we are going to, oh my, that is not the way we wanted to do that. Divide the numbers like normal, and then subtract the exponents on like terms using the rule. So you could even split this guy. So you kind of go, all right, well, what's this going to be? Well, this is going to give us 8 divided by 4. That's a 2. And then we're going to go subtract the exponents of my x's. And that's going to be 2 invisible 1 minus 1. And then we subtract our y variables, numerator exponent minus denominator exponent. And there's another invisible 1 right there. With these problems, I would really encourage you guys to put invisible 1s on variables that are by themselves. That's just going to help your brain, whether you're using any power rule. Anyway, let's finish up this problem. So we're going to combine those terms, and we got 2. 2 minus 1 is 1, and 3 minus 2 is 2. Bop. There you go. Also, side note, you don't necessarily need to have the 1 there, but if you want to put it, it would usually be fine. All right, hope that helps, and thanks for watching. Have a good day.